Good day, my name is Lapaz, and this my report about database normalization. Database normalization is a technique of organizing the data in the database. Normalization is a systematic approach of decomposing to tables to eliminate data redundancy and undesirable characteristic like insertion, update and deletion anomalies. It is a multi-step process that puts data into tabular form, removing duplicated data from the relation tables. Normalization is used for mainly two purposes: eliminating redundant useless data, ensuring data the dependencies make sense, i.e. data is logically stored. Database normalization is a process used to organize a database into tables and columns. There are three main forms: first, normal form; second, normal form; and third, normal form. The main idea is each table should be about a specific topic and only supporting topics included. Take a spreadsheet containing the information as an example, where the data contains salespeople and customers serving several purposes. Identify salespeople in our organization. List all customers your company calls upon to sell a product. Identify which salespeople call on specific customers. By limiting a table to one purpose is reduce the number of duplicate data contained within your database. This eliminates some issues stemming from database modification. To achieve these objectives, we'll use some established rules. This is called database normalization. As you apply these rules, new tables are formed. The progression from unruly to optimized passes through several normal forms: first, second, and third normal form. As table satisfy each successive database normalization form, they become less prone to database modification, anomalies, and more focused toward a sole purpose or topic. Before we move on, be sure you understand the definition of a database table. And this is the first table. Problems without normalization. If a table is not properly normalized and have data redundancy, then it will not only eat up extra memory space, but will also make it difficult to handle and update the database. Without facing data loss, insertion, updating, and deletion, anomalies are very frequent if frequent if database is not normalized. To understand this anomalies, let us take an example of a student table. And we have a first table. We have a rule number. First row is 101, second row is 102, third row is 103, and fourth row is 104. And in the second column is name. First column is Acon, second column is Bacon, third column is Secon, and fourth column is Deacon. Branch. As you can see, branch is also same as CSE. And next in HOD, and as you can see, it's still the same, Mr. X. And in the fourth, and the fifth column is office tel, and as you can see is still the same, 5337. Reasons for database normalization. There are three main reasons to normalize a database. The first is to minimize duplicate data. The second is minimize or avoid data modification issues. And the third is to simplify queries. As we go through the various states of normalization, we'll discuss how each from addresses these issues. But to start, let's look at some data which hasn't been normalized and discuss some potential pitfalls. And as you can see, we have a first table, sales staff, and in the first row is employee ID. Second row is 1003. Third row is 1004, and fifth and third row is 1005. And we go to the second row is salesperson. And we go to the second column is salesperson. First row is Mr. Smith. Second row is John Hunt, and third row is Martin Hack. And we go to the third column, sales office. First row Chicago, second row New York, third row is Chicago. And we go to the fourth column is office number. First row is 312-555-1212, and in the second row is 121-55-1212, and in the third row is 312-55-1212. And we go to the fourth column is customer 1. First row is Ford, second row is Dell, and third column is Boeing. And in the fifth column is customer 2. First row GM, second row is HP. And in the sixth column is customer. And we have a second column is Apple. Note, the primary key columns are underlined. The first thing The first thing to notice is this table services many purposes including 1. 1. 1. Identify the organization's salespeople. 2. Listing the sales offices and phone numbers. Number 3. Associating na so associating a salesperson with a sales office. Number 4, showing each salesperson customer. As a DBA, this faces a red flag. In general, I like to see tables that have one purpose. Having the tables serve many purposes introduces many of the challenges, namely data duplication, data update issues, and increased effort to query data. Data duplication and modification anomalies. Data duplication issues. Duplicated information presents two problems. First, it increases storage and decreases performance. Second, it becomes more difficult to maintain data changes. Notice that for each salesperson, we have listed both the sales office and office number. They are duplicate salesperson's data. Duplicated information presents two problems. First, it increased storage and decreased performance. Second, it becomes more difficult to maintain data changes. For example, consider if we move the Chicago office to Evanston, IL, to properly reflect this in our table. We need to update the entries for all the salesperson. Currently in Chicago, our table is a small example, but you can see if it were larger that potentially this could involve hundreds of updates. These situations are modification anomalies. Database normalization fixes them. There are three modification anomalies that can occur. Insertion anomaly. Suppose for a new admission until and unless a student options for a branch, data of the student cannot be inserted, or else we will have to set the branch information as NULL. Null. An insertion anomaly is the inability to add the data to the database due to absence of other data. For example, assume student group is defined so that null values are not allowed. If a new employee is hired but not immediately assigned to a student group, then this employee could not be entered in the database. Also, if we have to insert data of 100 students of same branch, then the branch information will be repeated for thus 100 students. These scenarios are nothing but insertions anomalies. Updation anomaly. What if Mr. X leaves the college or is no longer the HOD of Computer Science Department? In that case, all the student records will be updated and if by mistake we miss any record, it will lead to data inconsistency that results from data redundancy and a partial update. This is updation anomaly. Deletion anomaly. In our student table, two different informations are kept together: student information and branch information. Hence at the end of the academic year, if student records are deleted, we will also lose the branch information. Deletion anomaly occurs when you delete a record that may contain attributes that shouldn't be deleted. This is deletion anomaly. Normalization rule. Normalization rules are divided into the following normal forms. First normal form. Number 2, second normal form. Number 3, third normal form. And number 4, BNCF. And number 5, fourth normal form. First normal form. First normal form is a property of a relation in a relational database. Relation is in the first normal form if and only if the domain of each attribute contains only atomic values, and the value of each attribute contains only a single value from the domain. For a table to be in the first normal form, it should follow the following 4 rules. Number 1, it should only have single atomic valued attributes columns. Number 2, values stored in a column should be of the same domain. Number 3, all the columns in a table should have unique names. Number 4, and the order in which data is stored does not matter. Second normal form is a normal form used in database normalization. A relation is in the second normal form if it fulfills the following 2 requirements. It is in first normal form. It does not have any non-prime attribute that is functionally dependent on any proper subset of any candidate key of the relation. For a table to be in the second normal form, number 1, it should be in the first normal form. Number 2, and it should not have partial dependency. dependency. Third normal form is a database schema design approach for relational database, which is uses normalizing principles to reduce the duplication of data, avoid data anomalies, ensure referential integrity, and simplify data management. Now, the table is said to be in the third normal form when number 1, it is in the second normal form, number 2, and it doesn't have transitive dependency. How do you know if a relationship is 3NF? A relation is in 3NF if at least one of the following condition holds in every non-trivial function dependency. X determines Y. Number 1, X is a super key. Number 2, Y is a prime attribute. Each element of Y is part of some candidate key. What is 3NF in SQL? Third normal form. 3NF is a database schema design approach for relational database which uses normalizing principles to reduce the duplication of data, avoid data anomalies, ensure referential integrity, and simplify data management. How do I find my 3NF? Third normal form requirements. There are two basic requirements for a database to be in 3NF. The database must already meet the requirements of both 1NF and 2NF. All database columns must depend on the primary key, meaning that any column's value can be derived from the primary key only. Voice encode normal form, BNCF. Voice encode normal form is a higher version of the third normal form. This form deals with certain type of anomaly that is not handled by 3NF. A 3NF table which does not have multiple overlapping candidate keys is said to be in BNNF. For a table to be in BCNF, following conditions must be satisfied. R must be in third normal form, and for each functional dependency, X determines Y. X should be a super key. our 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 relation is in Boy's code normal form, BCNF. If every determinant in the table is a candidate key, determinant is any attribute whose value determines other values with a row. If a table contains only one candidate key, the 3NF and the BCNF are equivalent. BCNF is a special case of 3NF. What is the difference between 3NF and BCNF? This relation is in 3NF as it is already in 2NF and has no transitive dependency. Also, there are no non-prime attribute that is deriving a non-prime attribute. Why is BCNF used? Boy's code normal form or BCNF or 3.5NF is a normal form used in database normalization. It is a slightly stronger version of the third normal form, 3NF, called to address certain types of anomalies not dealt with by 3NF or organically finally defined. Fourth normal form is a normal form is used in database normalization. Introduced by Ronald Fagin in 1977. 4NF is the next level of normalization after Boy's code normal form. A table is said to be in the fourth normal form when number 1, it is in the Boy's code normal form. Number 2 and it doesn't have multi-value dependency. What is fourth normal form in DBNS? Fourth normal form 4NF is a level of database normalization where there are no non-trivial multi-value dependencies. Other than a candidate key, it builds on the first three normal forms, 1NF, 2NF, and 3NF, and the Boy's code normal form, BCNF. The table should not have any multi-value dependency. How do I find my 4NF? A relation R is in 4NF. If whenever X domain determines Y is a non-trivial MVD, then X is a super key. Non-trivial means that 1, Y is not subset of X, and 2. The definition of 4NF differs from the BNF definition only in the use of multi-value dependencies. Every 4NF schema is also in BCNF. That's all. Thank you.